I welcome you back. This video is suitable for students in Senior 5 and Senior 6. So I have said that now that I've explained how this reaction occurs and how disadvantageous is, the yellow precipitate which can be observed is for triiodomethane. What does iodine? This is what iodine does. It picks this part here and it substitutes the hydrogens there. It substitutes them. So meaning that if it is substituting the hydrogens, one can have CH3I. That is the first substitution. Another hydrogen, then you have CH2I2. Once you remove hydrogen, you add iodine. Then another one, you can have CHI3. Also, once the substitution continues, you can also have CI4. Yeah, but that one is unstable. Yes, it's unstable. It is close to non-existent. Yes. Then once iodine does that, observe that the yellow precipitate is for triiodomethane. Don't write this in your papers. Yeah, this is what I've told you that most students make that mistake. They write that this is not triiodomethane. I have said it can be formed, but it is not. It is a colorless. It is a colorless product. It is not the pale yellow precipitate. So once iodine takes the methyl group, so that we can have substitution. Once it does that, now this remaining part here. The remaining part is oxidized to a sodium salt of a carboxylic acid. Now we shall form CrOONA like that. There are some minor products depending on the textbooks that you have. In some textbooks, they add sodium iodide as a minor product. Yeah, but fundamentally, the major product is the yellow precipitate of triiodomethane. I take another example. Okay, maybe I take a specific example. I take a specific example of propanol. If I have propanol with the iodine in presence of sodium hydroxide on warming, what iodine does, iodine substitutes the what? Iodine captures this part here, the one that is close to Ca, that is close to CO, the one that is close to CO. That's what the iodine is looking for. So it captures that, then the substitution occurs so that you have CHI3. Then plus this remaining part is oxidized to a salt of a carboxylic acid. It is oxidized to a salt of a carboxylic acid. There are what? There are two carbon atoms that are left. There are two carbon atoms that are left. Therefore, we shall form sodium ethanoate like that. Yeah. Then there is also sodium iodide as a minor product like that. Now I want to say there is something which I have mentioned. I have said that. Okay, maybe I'm going to emphasize it down here. Sorry. Hope my meeting is not. Yeah, this. I am handling two masters at a go. Yeah. Okay. Another example is what? Is butanol. Butanol with iodine. In some books now you find them writing this. It is okay. Wow. So what does iodine do? Iodine is looking for a CH3 close to CO. It's looking for a CH3 close to CO, and it is here. Not the other side, it is here. So we shall form CHI3. It is a precipitate, by the way. the precipitate. Now this remaining part, are you seeing this remaining part? It is oxidized to a sodium salt of a carboxylic acid. There are 3 carbon atoms, so we shall get sodium propanoate. You get sodium propanoate, yeah, like that. So I put Na if here I add sodium hydroxide, but if I use hydroxide ions, the Na is not there. This is a propanoate ion, like that. Hope I'm clear. Now I have been mentioning what you can ask me. Sir, you are mentioning that the remaining part is oxidized. Yet earlier on you told us that ketones are not oxidized. Yet earlier on you told us that ketones are. Now this is the remaining part, not the ketone itself. Moreover, I want to say that, moreover, this mixture of iodine and sodium hydroxide, this is a strong oxidizing agent. Your teachers are going to teach you that halogens like iodine, halogens are very strong oxidizing agents. They are going to teach you that in organic chemistry. Now, a mixture of a halogen iodine in alkaline condition removes this part, it splits this compound. That's how powerful it is. It splits this compound so that oxidation occurs. However, they are not oxidized generally. It splits this so that you have a beta leaving group. A beta leaving group, this part here, this is the beta leaving group. It leaves very well so that oxidation occurs smoothly. So in this case, what am I emphasizing? I'm saying iodine and sodium hydroxide make a very strong reducing agent, moreover on warming. Once they are present and they are treated with ketones, the reagent causes the methyl ketone to split so that we have a beta leaving group. Now that we have a beta leaving group, now that the methyl ketone splits so that we have a beta leaving group, the remaining part can be oxidized smoothly to obtain a sodium salt or a carboxylic acid. Any ketone which is not in that form, any ketone which is lacking CH3CO is not oxidized. It's not oxidized. Also, in some books, you find this representation. Let me also make it clear. In some books, you can find out that. Let me use this. By the way, this is a methyl ketone. Hope you agree with me. It has a CH3CO. This is a methyl ketone. It has a CH3CO. Yeah. In some books, you find them writing this. Plus sodium hydroxide to form iodine, captures the other things so that you have a beta leaving group, the yellow precipitate, then plus the remaining part. Now, the remaining part here is this. This is our remaining part. This is our remaining part. That one there. So in this case, it is sodium benzoate that is obtained. The sodium benzoate that is obtained, then plus sodium iodide. This is in solution. This is also in solution. This is a yellow precipitate. This is in liquid form. AQ. In some books, you will find this representation. For those of you who read a lot of books, it is okay. Yeah, now I'm challenged with balancing it. If you write it in this form, you have to balance it. I don't know. I hate balancing equations. I hate balancing equations. I don't want. Yeah. So how can I balance it? Maybe I put a 4, a 3. I think there is a 3 there. If I put a 3 there, then those are 3 iodines. I'll also put a 3 here on sodium iodide. Then I'll also, so the iodines are balancing. There are 6 this side, also the other side there are 6. There are 3 iodines here, Also, the 3 which I have put here, would imply that I have 3 iodines. Then, which other one can I look at? The sodium. Are the sodiums balancing? The sodiums are not balancing. The other side, there are 4. We have 3 sodiums here and 1 sodium there. So how can I balance them? How can I hate balancing equations. Maybe I put a 4 here. I don't know. I put a 4 here. Will it give me what I want? Okay. I'll put a 4 there. So the atoms of sodium are balancing. The atoms of sodium are balancing. Now look at what? Look at hydrogens. Look at hydrogens. How many are they? On the left-hand side, I'm having 7 hydrogens. Hope you are agreeing with me that there are 7 hydrogens. But on the right-hand side, I have... there are those hydrogens on the benzene ring which I'm not counting. Yeah. Which I'm not counting. But will this still work? I think I have to change something. Will it work? Will it work? Will it work? I don't know. I think it doesn't. Should I leave it as an assignment? You all many people balance that equation, isn't it? Because for me, I don't want to balance. Okay. Let us see how to balance it. We have 3 iodines. The sodiums are balancing. The sodiums are balancing. However, what is not balancing? The hydrogens and oxygens are not balancing. Let us first deal with the oxygens. Here we are having 1 oxygen. 1 oxygen here. Then also 4 oxygens here. Those are 5. Isn't it? Those are 5 oxygens. However, this side I have 2 oxygens. Yeah, meaning that I have a deficit of how many? 3. Your side there are 5, this side there are 2. So meaning that to balance the oxygens, I'll add on 3 moles of water. 3 moles of water like that. Now, if I add 3 moles of water the other side, there are 6 hydrogens. There are 7. There are 7 hydrogens this side. These are 6. These are 6. Then plus 1 hydrogen here. Those are 7. Those are 7. Then also this side we have this 4 multiplies here. Those are 4 plus the 3 here. They are 7. So I think it is balancing. And in general, this is how it looks like by methyl ketone. In general, if you were to write it in that form, you have RCO CH3 plus 3 moles of iodine plus 4 sodium hydroxide plus giving us iodomethane plus the salt plus 3. This is not correct. This is a general equation. Sorry. This is a general equation plus this plus 3 sodium iodide plus 3 moles of water. Okay. So that is for methyl ketone. Allow me to stop here and